So our topic for today is all about recognized common isotopes and their uses. But first of all, we need to know what is isotope. What is isotope? Isotope is each of two or more forms of the same element that contain equal numbers of protons but different numbers of neutrons in their nuclei, and hence differ in relative atomic mass but not in chemical properties. The number of protons within the atom's nucleus is called atomic number and is equal to the number of electrons in the neutral atom. Each atomic number identifies a specific element, but not in the isotope. An atom of a given element may have a wide range in its number of neutrons. The number of nucleons in the nucleus is the atom's mass number, and each isotope of a given element has a different mass number. For example, carbon-12, carbon-13, and carbon-14 are three isotopes of element carbon with mass number 12, 13, and 14. The atomic number of carbon is 6, which means that every carbon atom has 6 protons, so that the neutron numbers of these isotopes are 6, 7, and 8. So how are we able to identify or know the numbers of proton, electron, and neutron? As I stated earlier, the atomic number of element is basically the number of proton and electron, while the neutron is the difference of mass number and atomic number. Here we have oxygen 18 as our example. The atomic number of oxygen is 8, which means the proton and electron is 8. How can we get the neutron? We have to subtract 18 to 8 and we'll get the neutron, which is 10. Also, there is two main types of isotope, which are stable isotopes and radioactive isotopes. Stable isotopes are non-radioactive forms of atom. It do not decay into other elements. Although they do not emit radiation, their unique properties enable them to be used in a broad variety of applications, including water and soil management, environmental studies, nutrition assessment studies, and forensic. While in radioactive, the unstable nucleus of a radioisotope can occur naturally, or as a result of artificially altering the atom. Atom with unstable nucleus regain stability by shedding excess particle and energy in the form of radiation. The process of shedding in the radiation is called radioactive decay. Now let us move to our main topic. What are the common isotopes and their uses? For stable isotopes, we have carbon-13 first. Carbon-13 is used in organic chemistry research, studies in molecular structures, metabolism, food labeling, air pollution, and climate change. It is also used in breath tests to determine the presence of Helicobacter pylori bacteria, which causes stomach ulcer. Number 2 is carbon-12. In 1961, carbon-12 is selected to replace oxygen as the standard relative to which of all the weights of all the elements are measured. Number 3 is nitrogen-15. Nitrogen-15 is used in treating acid-related disease of the stomach and intestine, such as arginonosinic aciduria. And number 4, deuterium. Deuterium is used as tracer in nuclear fusion reactors to slow the neutrons in heavy water-moderated fission reactors. Deuterium was discovered in 1931 by Harold Urey. He used a new form of hydrogen to produce samples of heavy water. Let's move on to radioactive isotopes. First in radioactive isotopes is phosphorus-32. Phosphorus-32 is used in cancer detection and treatment, especially in eyes and skin. It is used in laboratory to label DNA and proteins. It has been used to treat blood disorder called polycythemia vera and certain types of leukemia, but not commonly used anymore. Next is iron-59. Iron-59 is used as tracer in study of iron metabolism, determination of blood volume, and in blood transfusion studies. Next, we have cobalt-60. Cobalt-60 is used medically for radiation therapy as implants and as external source of radiation exposure. It is used industrially in leveling gauge and X-ray welding seams and other structural elements to detect flaws. Cobalt-60 also used in food irrigation, sterilization process. Next, we have iodine-131. Iodine-131 is used in medicine to diagnose and treat cancer of the thyroid gland. And lastly, we have plutonium-224. Plutonium-224 production at the Savannah River site. Its primary purpose was to produce special nuclear materials for national defense, specifically weapons-grade plutonium and tritium, required for thermonuclear devices. Is Gianabel Suarez from STEM 11 Pollard. Thank you for listening and have a great day ahead.